right, today's lesson is going to cover volume of pyramids and cones. So if you have your notes, this starts on page 8. So the volume formula for any pyramid and cone is volume equals base times height divided by 3. Or you could also do 1/3 area of the base times the height of the pyramid and cone. And just remember, capital B, it means the area of the base shape. So just as an example, the height kind of goes from the tippy top straight down to the base face. And then we still have that slant height as well that might come into play. And then as well as the cone, the height goes from the tippy top point down, straight down to basically the center point of the circle. And then again, slant height, you see the right triangle. So we may have to use Pythagorean theorem if we need to find the height or the radius. All right, so without further ado, here are some examples of finding volume of pyramids and cones, and they want us to round to the nearest tenth when necessary. So for this first one, we have a square-based pyramid, so these ones are nice and easy. So 11 times 10 will give us the area of the base. Here is the height of the pyramid times 16, divide by 3, and we get a volume of 586.7, if I round to the nearest tenth, cubic inches. Pretty nice and easy with that one. Moving on to example 2. So now this one, I see they gave a slant height, but we don't have a height down from the top to the middle, so we're going to have to do some extra work here by drawing in the height and then also the right kind of bottom of the right triangle. This will, since this is a square, I can tell it's a square base pyramid because it's 14 by 14. So this piece is 7, and we are going to need to find the height using the Pythagorean theorem. So 7 squared plus height squared equals the hypotenuse, which is that slant height, 25 squared. And if I do all the math, I end up with h equals 24. So the height of the pyramid is 24. So now I have everything I need to find the volume. So volume equals the area of the base, so 14 times 14, times the height, which is 24, divided by 3, and I get a volume of 1,568 cubic feet. All right, moving on to the next example, which is number 5. So let's see, this is a triangular pyramid. I see we have the height, but if I look real close, that right angle for the base triangle is there. So here is the base of that triangle and the height, and this is the hypotenuse, but I need this length here, so I'm going to need to use the Pythagorean theorem to find that length there. So 14 squared plus, I don't know, let's label that b. b squared equals 22.1 squared, and when I do all the math there, I end up with b is approximately 17.1 meters. So now I have enough information to find the area of the base shape. So now 14 times 17.1 divided by 2 because it's a triangle. And then, so this is B, capital B, equals about 119.7. That's the area of the base, so then I'm going to plug it into the volume formula. So area of the base times the height of the pyramid, which is 19, divided by 3, and I get, oops, I'm going to run out of room here. We'll go over this way. So the final volume is, make sure I'm on the right one, 758 1/10 cubic meters. All right, moving on to cones. So I have the whole diameter is 5, so the radius is going to be 2.5. So volume equals the area of the base, so pi r squared, so 2.5 squared times pi times the height of the cone, which is 8, and then divide by 3. When I do all that math, I end up that the volume is approximately, oops, where's my approximately 52 1/3 cubic inches. Again, I'm just trying to make this video as short as possible, so you should pause and practice typing into your calculator and double check that my answers are correct as well. All right, moving on to the next page, we have another cone, but in this example, we do not have the height. So we're missing the height, but again, this kind of makes a right triangle, so we're going to use the Pythagorean theorem. I'm going to cut 27 in half to find that base length. So half of 27 is 13.5. So now I'm going to quick do 13.5 squared plus that height squared equals the hypotenuse, which is that slant length right there, 22.5 squared. And then when I do that, the height ends up equaling 18 kilometers. All right, so then the next part is, now that I have the height, switch colors here. So now I'm going to do the volume equals radius squared times pi times the height divided by 3, and the volume ends up approximately being 3,433, and I think it was rounding to the nearest tenth, right? So 0.6 cubic kilometers. All right, and we have a word problem. So it says if a, oh, this is wrong. So this should have been, let's change this. So if a cone has a volume of, this is surface area, so switch this, 1,309 cubic centimeters, and a height of 8 centimeters, so just scribble out that one. Find the radius. Find the radius of the cone. So we're going to kind of work backwards here because we're given the volume. So I'm going to plug in the volume number equals pi times radius squared. We don't know that. That's what we're asked to find. Times the height, which they said was 8. Divide by 3. Squiggle solve. So I'm going to multiply both sides by 3. And I get 3,927 equals radius squared times pi times 8. And then pi times 8 is approximately 25.12. So then we'll divide both sides by 25.12. And I'm running out of room here. So I'm going to go over here, which ends up being 156.33 equals radius squared, square root, and we get that the radius is approximately 12.5 centimeters. All right. Here it says, Caitlin must build a sandcastle in the form of a square pyramid for a project. As shown to the left, she bought 3 bags of sand, each containing 1,200 cubic inches of sand. Will she have enough sand to build the sand castle? So we're going to find the volume of the sand castle and then see if she has enough sand to build it. So volume equals the area of the base, 25 times 25. We have the height, which is 18, divide by 3, and we end up that the volume is 3,750 cubic inches. So this is how much she needs for sand to build. And then she has 3 bags of sand, each containing 1,200. So we're going to do 3 times 1,200, which is 3,600 cubic inches. So does she have enough sand to build the sandcastle? No, she doesn't have enough sand. She is 150 cubic inches short. All right, and now we're at the last one. So this one says the cylinder to the left contains 2 congruent hollow cones. So these right here are empty space. If the cylinder's height is 20 inches, so I'm just going to quick label that there, 20 inches, and its diameter is 14 inches, find the volume of the solid. So it's kind of like shaded region. I'm going to need radius equals 7. So we're going to do the volume of the cylinder first, the whole thing. So radius squared times pi times the height of the cylinder, divide by 3. No, not divide by 3. This is a cylinder. Never mind. So when I do that, I get the volume of the whole cylinder is approximately 3,077.2 cubic inches. But then we're going to do volume of the cones. So since there's 2 of them, we're going to multiply by 2. So radius squared times pi times the height of each cone, which is 10, because it's half, divide by 3, and I get the volume of the cones is approximately 1,025.7, and then our last step is to subtract 3,077.2 minus 1,025.7, and we get the volume is approximately 2,051.5 cubic inches. All right, that is the lesson on volume of pyramids and cones. Now it's your turn to practice with the assignment. Don't forget to submit a picture of your completed assignment to Google Classroom, and then have it ready to correct and ask any questions the following day in class. Thanks, everyone. Bye.